Have you ever wondered how your code gets compiled and linked together, especially when it comes to templates? It can be a bit confusing, right? If you're curious about how identical template instantiations are handled across translation units, you're in the right place. Today, we're diving into the fascinating world of linkers and templates. I totally get it. It can be frustrating when you have multiple translation units and you're not sure how the linker manages identical template instantiations. You're definitely not alone in this confusion. Many developers face this challenge. Let's set the stage with a specific example. One user asked, how does the linker handle identical template instantiations across translation units? They provided two translation units, foo.cpp and bar.cpp, both instantiating std_vector int. Sound familiar? If so, let's explore this together. So how does the linker manage this? When you compile foo.cpp and bar.cpp, each file creates its own instantiation of std_vector int. But what happens at the linking stage? This is where things get interesting. And stick around. At the end of this video, I'll share a key insight that will help you understand linking better and improve your coding practices. To understand how the linker handles identical template instantiations, we first need to clarify what happens during the compilation of each translation unit. In our example, both foo.cpp and bar.cpp instantiate std_vector int. During the compilation stage, each translation unit generates its own object file. This means that foo.cpp and bar.cpp will each have their own version of std_vector int in their respective object files. Now, when the linker processes these object files, it recognizes that both instantiations of std_vector int are identical. The linker uses a process called duplicate elimination to handle this. As a result, both instantiations do not have different mangled names. Instead, the linker will keep only one instance of std_vector int in the final executable, effectively removing the duplicate. In summary, the linker efficiently manages identical template instantiations across translation units by eliminating duplicates, ensuring that the final executable remains optimized and free of redundancy. Fun fact. The term mangled names comes from the way compilers encode function names to include type information. It's like a secret code that helps the linker do its job. Now, let's look at the answers provided by other users. This user explains that when a non-template class like bar is defined in a header included in multiple translation units, the linker will not create multiple definitions in the final binary. Instead, it performs what's called linkage collapsing. This means that even though there are two definitions in the object files, the linker resolves them to a single definition in the final binary. This behavior is guided by the one definition rule, or ODR, which ensures that definitions are identical in semantics. The same principle applies to template instantiations, like std_vector int, where the linker treats them similarly. Here's a pro tip. Always be mindful of template instantiations in your code. Understanding how the linker works can help you write more efficient and cleaner code. And there you have it. Now you know how the linker handles identical template instantiations across translation units. Remember, understanding these concepts can greatly enhance your coding skills. If you found this video helpful, don't forget to subscribe for more insights and tips.